what we're going to do is we're going to reverse the operation and try to figure out what is the equation of this graph using some information that we have down here. So if we've given some information about the graph, has a base of 1/2, all right? So a base of 1/2. It's a decay function. This does look like a decay function, but it does look like it's being shifted downwards. Because remember, it used to have a horizontal asymptote of y is equal to 0. But now we have a horizontal asymptote of y is equal to -4. So that's probably going to help us later on to figure out some pieces. Remember, the only way to change the asymptote, not the stretching or anything like this or moving side to side, the only thing to move this asymptote because it's horizontal is if I move it up or down using my k value. So some of the key things about this is being translated. So that's probably just h and k. Nothing to do with a and b because they haven't said the word transformed. So not doing any stretching to this graph. We probably could put an a and b in there and try to solve what they could be. They probably end up being 1 and 1. And then right now we're going to determine the graph, the equation of this graph. Okay, so we're given 2 points here. Usually if you're given 2 points or we can read 2 points, we probably have to create a system of equations because we have 2 unknowns. But we already know one of the unknowns because of how the graph looks is being shifted downwards 4 units. So what I already know, because of the asymptote, my k value is -4. So this is what my equation looks like so far. I don't know my h value, but I know there's a -4 here. Okay. So I'm going to use one of these 2 points here now to solve for what my h is. And all this is just saying if I put a 0 in, I get a 4 out. If I put a 1 in, I get a 0. So I just pick one of them, doesn't really matter. Let's just say I pick the, let's put the 0 in. So let's say I put 0 into this equation, minus h. I need to get 4 out. So I'm going to rearrange this. I'm going to add that 4 over to the other side. Just simplify this slightly. Now we got to figure out what the h value has to be to make this work. Now remember, there's a few different ways to do this. We can change this into logarithm form and solve for the h. We've seen some of that already. Okay, we just applied the log, one of those log forms to this. Or we can change the base. I notice that here I can change this to, rather than being a 2 or a half here, I can change it to be a 2 to the power of h. So I can say something like that. Right, so remember that little negative exponent will take the reciprocal of this. So that's what this looks like. And then I can change the 8 to be 2 to the power of 3. So what I know is that the h is 3. That's one way. Or if I use my log, my exponential form, I can change this into this form, and I can say the log of base 1/2 of 8, and that is equal to -h. Now, if I did the math on this side over here, I would get a -3. -3 is equal to -h. h is 3. So either way, I get the same answer. So I can change the log form, solve for the exponent, or I can change the base, solve for the exponent. Both are acceptable ways here. Sometimes you can't do the change the base because there is no common base between the 2 numbers that we picked. Like here, 2 and 8 work because I could change 8 to a 2. But if this was a 5, I can't do that. So we just have to change in the log form to solve for h. Okay, so now we know h and k. I'm going to create my equation here. So I have x minus 3, and then I have a -4. Now you probably want to just verify to see if this actually works for the other point. Because if it doesn't work for the other point, then there must be a b or an a value that's going to change the point around. So I'm just going to do a quick little verifying here for 1, 0. I'm just going to do it up here. So you might want to verify here. I didn't change the size of this marker. Let's put it down a little bit smaller. I'm going to verify. Okay. So I want to get 0 when I put in a 1. So let's just double check here if that's going to give me what our result. So we have 1/2 to the -2. So 1 minus 3 is -2. 1/2 to the -2. Remember our rule down here, I can take the reciprocal. So this is 2 to the 2 minus 4. This is 4 minus 4, which is 0, which is what we wanted. So that point works, and this point works, because we use this point to create the equation, so it must work. So it passes these 2 points. So everything works. That's good. All right. So let's check out our next one here. So we're going to do the same thing again. You notice that this graph is upside down. That's fine. We'll fix that as we go. But before we start, I'm just going to mention what our horizontal asymptote is. It looks like our scale here is by 1. So the horizontal asymptote is y is equal to 2. Okay, so now we have this. It's being reflected. It's being translated. Well, I kind of know it's going to be reflected because it's upside down. All right, has been reflected more than one way. This 4 here, maybe it's being reflected more than one way, but it doesn't look like it has. It looks like it's being reflected one way. It looks like the graph used to be going this way. Makes it a growth function because this number is greater than 1. So remember that. Okay. So it's upside down. We got a single point here that's going to help us out. They only gave us 1 point this time because we can use the asymptote to find our k value. So we already know one thing about our graph. We can use the other point to find out our h value because we already know our a value is negative. And they don't say anything about any other transformations, like it means stretching horizontally or vertically. So we have this equation so far that says y is equal to negative bracket 4x minus h plus 2. So all this is now saying is that if I put a 4 in to my x value, I get a negative 2 out for my y. So if I put a 4 in here, let's put a 4 in here, I actually get a negative 2 out. All right, so I just do a quick little rearranging here. So I'm just going to minus the 2 over to this side, I get negative 4, and then I get like this. Okay. Both sides are negative, so if I were to divide this negative over, this would turn positive, positive. So what we have now is 4 is equal to 4 to the 4 minus h. Okay. Because they both have the same base, that means their exponents have to be the same. So the exponent on the 4 on the left side is a 1. So that means the exponent on the right side must also equal 1. So based on my math here, h is equal to 3. Another 3. So my equation, I'm going to write this out again, negative 4x minus 3 plus 2. That's my equation. Yeah. Isn't bad? Pretty easy. All right. It says here determine the expression for the y-intercept. Now remember to find the y-intercept. To find the, oh, I don't want to write there on you. Okay. To find that y-intercept, we make x equal to 0, and then we just do the math. So let's see. We got 2c. Well, if we have a c here, so they want to find an expression. So they don't want you actually find a number. They want to just a simplified expression with the c in there, because I don't think the c is going to disappear in this case, because if my x is equal to 0, my exponent will be 0 plus 2, so that should be 2 in the exponent. So this would be c squared minus 1. There's nothing I can really do here to simplify this down because I don't know what c is. So my y-intercept is going to be 0, 2c squared minus 1. There's my y-intercept. Looking pretty good. Now this other part over here doesn't really matter. This could have been a decay function from 0 to 1 as well. It just can't be 1. Well, I guess it could be 1. It just looked kind of weird if it was. Okay, determine the equation of the horizontal asymptote for this one. So we go to the horizontal asymptote. And remember, the only thing that can affect the horizontal asymptote is your k value. Stretching it and reflecting it doesn't really move, doesn't move the horizontal asymptote. Moving a horizontal line side to side just keeps that horizontal line where it is. And even squishing, but there's no b value for this one. So the 2 is the only thing that's going to affect this graph. And remember, the horizontal asymptote of the original graph, c to the x, say that's my original graph here, its horizontal asymptote is y is equal to 0. So that means if I moved it up, my new graph, which is a bunch of stuff here, plus 2, because of the plus 2, my new horizontal asymptote is 2. Let me just write that beside that. There we go. Now again, this part doesn't really matter because they both have the same horizontal asymptote to start off with. It doesn't matter about the form or if it's decay or not. Determine the range of this function. Okay, so now the key to this range is that if you look at the original graph, y is equal to c to the power of x. And the range of that graph, before we did anything, there's no a, b, c's, or d's on this graph here. The range of this graph is y is greater than 0. Remember, it can't be 0 because there's no way to ever make this equal to 0, and it can't be less than 0 because it just doesn't mathematically make sense. YER. I just forgot what I was doing right there. Now, the things that are going to affect the y value will affect the range. So, like this negative in the front will probably affect the range. This 4 will affect the range, but this negative here is not going to do anything because that's the horizontal stuff. So that could affect the domain. But remember, our domain, if I want to write that over here, just so we can refresh our memories on it, is XER. I might as well do the domain and range for this graph as well. So with this negative, which is going to do something to our graph, and that minus 4 is going to do something to our graph. So let's see what that's going to do. So a negative graph. So remember our original graph looked like, because I'm just going to draw my original graph. I don't know. Oh, this. You see the c value is a decay function. So that's what the original graph looked like. Okay. Now, if I do a reflection over the x-axis, it's going to look like that. So that means I'm going to have a less than sign here because I've done a reflection. And then I'm going to move the thing down 4 units. So this line I drew here is no longer 0. It was y is equal to 0. And now that line is y is equal to negative 4. Okay. And then YER. I've done a horizontal reflection here too. So this graph actually doesn't look like this. It actually looks more like this. That way instead. But you notice that does not change the domain. It still goes off in both directions, right? So that ends off our lesson for transformations of exponential functions. We'll continue on. We'll do some transformations of logarithm functions in the next video. All right, see you then.